In this video, we will be discussing the one-way chi-square test. I'd like to start by sharing with you a quote. And this quote comes from William James. It says, "To study the abnormal is the best way of understanding the normal." And what does that mean? It means that sometimes the data we retrieve from our research is not normally distributed. And in this graph, I show you where a non-normal distribution would suggest that the mean is not in the center of the distribution. So if you notice, the tail of this distribution graph is skewed to the right. And so we say that this is right side skew, meaning that the mean, mode, and median doesn't appear in the center of the distribution. And if our data does not meet the normal distribution, it is said that the parametric assumptions, which are the underlying assumptions for statistical tests, such as conducting or carrying out an average or a mean, cannot be met. And if these parametric assumptions are not met, then the choice of statistical test that one uses to analyze the data is influenced. Particularly if we are looking at the chi-square test, it is used when our data is represented as frequency or percentages. So I'm looking at differences in the percentage of men versus the percentage of women who use marijuana, or I may be looking at the percentage of men and or women who practice physical activity 3 times per week. To tell the difference between the frequency or the percentage, I will use a one-way chi-square test. In this test, the participants are grouped into categories and we compare the expected value to the observed value. We also need to calculate what is known as the degrees of freedom to find our critical chi-square value, similar to what we did for our t-test. To calculate our degrees of freedom, we do the number of rows in our table minus 1 times the number of columns minus 1. And I'll show you what that looked like more specifically in another slide. After doing the degrees of freedom and finding our chi-square statistics, we want to calculate our calculated chi-square and arrive at a decision rule. Our decision rule usually is that if the calculated chi-square statistics is greater than the critical chi-square statistic, we reject the null. Again, a similar principle to what we looked at when we spoke about the t-test. The formula for the chi-square statistics is very simple. It is the summation of the observed count minus the expected count square divided by the expected count. And this is something we are going to explore in an example in this slide. We carry out the chi-square test using the same 7-step principle as we do for all of our other hypothesis testing. And we start out by defining our null and our alternative hypothesis. We define alpha, we calculate our degrees of freedom, and find our critical value, which is our chi-square statistics value, using the chi-square distribution table. Then we state our decision, which is if our chi-square calculated is greater than our critical chi-square statistics, we reject the null. Once we calculate this chi-square statistics, we are able to state the results and formulate our hypothesis. And formulate our conclusion rather, based on the hypothesis. So with the one-way chi-square, what we are asking is, do two groups or more differ on one variable category? So does the percentage of men differ from the percentage of women who use marijuana. So our one variable we're looking at is marijuana use, and the two groups we are comparing is men versus women. This is different from our t-test in that with our t-test we are comparing means, but with our chi-square test we are comparing proportions or comparing frequency or percentage, all the same thing. So now I'm going to take a look at an example. And with this example, we'll go through the 7-step principle and arrive at the conclusion. So the Georgia College Wellness Center wants to determine if the frequency of depression is different between men and women. For this, we will do a one-way chi-square test. Here is our table. Collecting data from the Wellness Center, we observe that there are 60 persons in total. So here we have 60 persons, and 24 of them are men, 36 are women. Our hypothesis therefore suggests the null that the number of depressed men is equal to the number of depressed women. Our alternative hypothesis suggests that the number of depressed men is not equal to the number of depressed women. We define our alpha as 0.05, and that takes us to step 2. If we go to step 3 then asks us to complete what is known as our degrees of freedom based on our distribution table. And I want you to recognize that the table has changed. So in the first row of our table, we have what we observe as the distribution. However, if the null hypothesis were to be true, what would be the expected distribution? The expected distribution would be that 30 men would be depressed and 30 women would be depressed, which gives us a grand total of 60. And this would mean that our null hypothesis is true, that 30 men are depressed and 30 women are depressed, which suggests that the percentage or frequency of depression is equal. So what we want to do is we want to test if this is true or if this distribution in the observed is statistically different. So for that, we calculate our degrees of freedom, and we have 1, 2 columns, and we have 1, 2 rows. So it is 2 minus 1 times 2 minus 1, which is equal to 1. And that's how we arrive at our degrees of freedom of 1. We're looking at our chi-square distribution, and we follow a similar procedure that we do with the t-test, in that on the column over here, we identify our degrees of freedom, which is 1, and so we identify that here as 1, and we identify next our alpha, which is 5, which is 5%, and this is what you're going to look for, the 5%, because this is proportion. You're not using the 0.05 this time, you're using 5%, because on this row it is representing percentage as a probability and not the decimal. Okay, the next step is then to identify what would be our chi-square critical value, and if we follow our degrees of freedom of 1 and our alpha of 5% or 0.05, we get 3.841. Using that, we arrive at our decision rule. If the calculated chi-square statistics is greater than 3.841, then we will reject the null hypothesis. To calculate our chi-square statistic, we simply follow the formula that says we have our observed count minus our expected count, and we want to square that, and then eventually we are going to divide that by the expected count, and then we are going to sum everything together. So we break this down into the parts of the formula. So the first row is observed minus expected, and so we do 24 minus 30, which gives us negative 6. We do 36 minus 30, which gives us 6. That number that we have up here is now squared. 6 times negative 6 times negative 6 gives us positive 36. 6 times 6 gives us 36. The next thing the formula requires for us to do is to divide these number by the expected count. And the expected count, as we know, is 30. So it is 36 divided by 30, which gives us 1.2, and 36 divided by 30, which gives us 1.2. The next thing the formula requires for us to do is to sum all of these numbers. And so when we do a sum of 1.2 plus 1.2, we get 2.4. Hence, our chi-square statistics is 2.4. And at this moment, feel free to pause the video and to go that over again until you get it, because this is a very important step. So again, our chi-square statistics is 2.4, and we know that 2.4 is less than 3.841, and therefore we cannot reject the null, and so we say the result is that we fail to reject the null, that there is no difference between the frequency of depression between men and women. So how do we then state our conclusion? We go and we state our conclusion by saying there is no difference in the frequency of depression between men and women. Our chi-square statistics calculated is 2.4, and the p-value, which is representing our significance value of alpha, is greater than 0.05, which means that this is not a statistically significant result. This is now a similar example using data on condom use among men and women, and what we're asking you to do in this slide is to conduct the chi-square statistics test to identify if the frequency of condom use differ from men and women at Georgia College. Take your time, go over the video, and then attempt this particular practice on your own.